In 1909, Rutherford began noticing that when he fired alpha particles, helium nuclei with two positive charges, at a piece of gold foil that would not always behave in accordance to J.J. Thomson's plum pudding model, which stated that an atom was a vast amount of empty space that pretty much anything could pass directly through. This discovery inspired Rutherford to run and publish his gold foil experiment in 1911. In 1911, Rutherford had his two associates, Hans Geiger and Ernest Marsden, set up and run his experiment. To do this, Geiger and Marsden had a thin piece of gold foil, alpha particles, a microscope, and a zinc sulfide foil backdrop. Here, our alpha particles are represented by two people, our gold foil represented by the aluminum foil, and our zinc sulfide backdrop is represented by this wall. From previous experience, Rutherford knew that alpha particles let off light when they hit the zinc sulfide wall. In order to see this light, Geiger and Marsden conducted the experiment in complete darkness, in the aid of a microscope to both detect the light and the position of the alpha particle after passing through the gold foil. Now that the experiment was set up, Marsden and Geiger could begin. So, they fired alpha particles at the gold foil and observed the position of the particles. As previously stated, according to the plum pudding model, the alpha particles should have easily passed directly through the gold foil. For the most part, this is exactly what happened. However, there were some particles that deflected slightly from the direct path by about 1 or 2 degrees. Perhaps the biggest discovery was that about 1 in every 20,000 alpha particles would deflect 90 degrees or more from the straight beam, and some even bounced right back to the direction of the beam. Thus, the results allowed Rutherford to draw two conclusions from his findings. First, he concluded that an atom must be much more than just empty space, and also that an atom must have a positively charged center that contained most of its mass, since the positive alpha particles were deflected from the straight path. Also, since very few particles deflected slightly from the straight path of alpha particles, and even fewer bounced straight back, the dense positive center must be much smaller as compared to with the rest of the atom. Rutherford's discovery was incredible, and allowed for the continuing of discovery by other chemists in the chemistry world.